Okay, let's do a revision on terminal velocity. Just focus on terminal velocity, right? So this one, I know sometimes poses some challenge to students. Can understand but find it hard to write and get all your marks and describe properly. Okay, first place you must learn and you must memorize the definition of terminal velocity. What is terminal velocity? Okay, can try not to use your own words. Okay, you use your own words, you often leave out words. So is the maximum constant speed achieved by a free falling object when the gravitational force is equal to the resistive forces causing the resultant force to be zero and the acceleration to be zero. Okay, so that is the proper definition for it. Okay, so you very often asked, describe what happens to object during free fall in terms of forces. Okay, so well, this is, if it's just fill in the blanks, I guess you will be able to do it. Okay, so how to try to remember this? Okay, I'm trying to think of a good way to help you remember all this that you need to write. Okay, so what you start off with? Okay, maybe you can start off with a mental idea. Okay, so you start off with number one. Okay, you think. Okay, what are the forces? State down the forces acting on the body, okay, on the object. So usually it's free falling in air. Okay, maybe it's water or some liquid or oil, whatever. So there is the weight acting on it, gravitational force acting downward on it, and there's the air resistance or liquid resistance acting upward on it. Okay, so we start off talking about what are the forces, acting on it. All right, so two, right, the second line, second paragraph. Okay, at the moment of it falls. Okay, just the moment at the moment. Okay, right at the very start. Okay, at the very start. Okay, what happens? Okay, you need to talk about what? Okay, the speed. Well, what are the things we're going to talk about? Okay, so when we think about the things we talk about, there's so many things we often forget. Right, we try to recall everything. We forget. Okay, when we talk about this, okay, let me give some guidelines. We talk about the speed. All right, we have to talk about the speed. Then think about this. Remember this, I told you before many times. Force equals ma. And the second line is very important. Force motion minus force opposing equals ma, which in this case, okay, is the weight and the air resistance equals ma. Right? This is helpful. Why do I say helpful? Because it helps you remember what you need to talk about. Okay, so I need to talk about the speed, I need to talk about the weight, I need to talk about the air resistance, I need to talk about the acceleration, and then I need to talk about the resultant force. Okay, so 1, 2, 3, 4, 5. Can remember? One. Okay, what order you want is up to you. 2, 3, 4, 5. These are the 5 things you can talk about. Okay, so at the very start, what is happening? Speed 0. Okay, at the very start, speed 0. Just the moment you release what? Speed 0. What are the weight acting on it? Yes, there's gravity acting on it, but acceleration is, not acceleration, the air resistance is also 0. Why? Because it haven't even start falling. Okay, so this is 0. Okay, and there's what kind of acceleration does it fall with? Then it will be falling with gravitational acceleration. And what's gravitational acceleration? 10 meters per second squared. And so it will falling due to what? Gravitational force. Okay, so you talk about the 5 things. All right, so 1, 2, 3, 4, 5. You talk about the speed, you talk about the weight, you talk about the air resistance, you talk about the acceleration, and then the resultant force. Okay, then the story really begins here. That's why it's so long and quite difficult to remember, right? Okay, as it starts to fall, as it starts to fall, what happens? Okay, same thing. Okay, 1, 2, 3, 4, 5. Let's talk about first one. Speed is increasing. Okay, speed is increasing, getting faster and faster. The weight don't change, constant, right? Okay, why? Gravitational force acting on it is constant. Okay, as you fall, just always remember this. As you fall, you don't become heavier, you don't become lighter. Air resistance, what happened? Increasing. Why does air resistance increase? Because speed increase. okay, then as weight is constant, air resistance is increasing, what would happen to the resultant force? Maybe it's easier to talk resultant force first. So this one same, this one keep going up. Your resultant force, F stands for resultant force, is decreasing. And as it decreases, acceleration also decreases. Okay, so remember this, Okay, so it keeps on getting faster and faster and faster. Then after that, fourth thing to talk about is that once the air resistance, okay, now we talk about air resistance, first is equal to the weight. Then what happens? It's the usual four things, which I keep on saying. Air resistance equals the weight, resultant force is 0. Resultant force 0, what happens to acceleration? Acceleration is 0. And now what happens to the speed? Speed is constant. Okay, so it is now falling at constant speed known as terminal velocity. Okay, so that's how you go about explaining the process terminal velocity. Okay, why you find it so difficult is because there's so many things to explain, right? And tendency is that we forget to talk about something along the way, or we write the wrong thing down. Okay, so but basically you have to talk about the weight, the air resistance, the acceleration, the resultant force, and the speed. So try to break it out in that way, and maybe it's easier. So we start off with talk about forces acting on object. Then at the very start, before you even start, just the moment you drop it, at the very start, okay, talk about all of them. Then after that, you talk about as it falls, what happens, and then the crucial bit, what happens when the air resistance equals to the weight. That reaches the terminal velocity part. Okay, so this takes some effort to practice. So you can just what you can do. Okay, try to read through what you have learned. Okay, read through all this, and then after that, okay, take a blank piece of paper, try to write it down by yourself. Okay, try to break it into parts so you can remember, like what I said. Okay, the forces acting on object at the very start. Okay, right at just as it's being released, then once it starts falling, and then what happens when the weight equals air resistance. Okay, so you have to practice this because it's not easy. Okay, other things easier to remember is the graph. This one all of you know. I think I don't need to draw for you. Okay, you all know that it looks like that, right? So where's terminal velocity? That one you also know, right? Terminal velocity is when the speed becomes constant. So this is your velocity, this is your time graph. Okay, so sometimes they will just change the question, ask you, okay, why is the shear graph in this manner? So it's basically the same thing. The question can come in all directions, all forms, but basically asking you for the same kind of explanation. Okay, so also remember, okay, other than the explanation, definition, the graph, what does it depend on, right? Terminal velocity would depend on the density and medium. Okay, medium is falling in. Okay, it also depends on the weight of the object, right? So the weight of the object also plays a part. So if the object's weight is really large, okay, then your terminal velocity will be much higher. Okay, the weight of object, and then also it depends on the surface area, right? The surface area matters. Why? If the surface area is large, it will generate a greater amount of air resistance. Okay, so sometimes you're being asked about this, and then when you ask about this, you need to explain further on. Okay, one thing I would like to remind you is that, okay, terminal velocity is only for, like the definition goes, free falling objects. Do not say, which some students like to say, the object or the car is moving at terminal velocity along the road. Cannot. It's only for free falling objects. Okay, so this takes some effort, some time to study, and then of course go and look as usual at your questions you have done. Okay, this typical O-level question. Okay, then you go through and ask yourself, hey, can I describe the acceleration? Okay, how do I describe? Remember, I always use keywords, what? Increasing, decreasing, constant, zero. Go and describe. Just ask you describe, never ask you explain. Then after that, they ask you explain, okay, or calculate. Okay, you can do it. 2 lines, do calculation, explain. Okay, then that is where hopefully your effort in studying pays off. You can remember what are 5 things to write about for every section, okay, every part. And then here they challenge you further. Okay, what happens why the stone reaches terminal velocity in the seawater. This one is actually the other way around. Okay, so the other way around means what? In the seawater, it hit the seawater at very high speed. Then after the speed start decreasing until it was equal to the weight. I mean the water resistance became equal to the weight, and then the whole process is again just like what I wrote here. Okay, in short. Okay, so it's good to first you need to study, memorize. Then after that you need to practice. Go through the questions you've done before, read and see how you answered it. Okay, so hopefully this 10-minute or 11-minute revision of terminal velocity helps you. Okay, but you have to go and study yourself. There's no shortcut. I can't study for you.